revision on the directional senses. Okay, so remember I told you that these directional senses are very important. So I have a few questions and I'll be asking them quick, and you need to answer. These crossed lines, these cross marks represents the direction of magnetic field in a region. In a region, these cross marks represent the direction of magnetic field. So now, direction of magnetic field cross mark ke represent kora mane hocche the magnetic field lines are going into the plane of the board. তো এখানে আমরা দুটো directional sense শিখেছি, একটা হচ্ছে dot circle মানে হচ্ছে the vector is directed out of the plane of the paper perpendicularly out of the plane of the paper. And cross circle means the vector is directed perpendicularly into the plane of the board. Right? So over here, the magnetic field lines are directed into the board, means they are coming from that wall to this one. Alright? So if I take a positive charge, remember a positive charge, and throw it in the vertically upward direction, means I throw the positive charge along this direction with a velocity v. Okay? So, Sailesh, which direction will it experience the force? ये v किस direction में force experience करेगा? v के. Well, so in this case, the velocity is directed upwards. So if we apply the FBI rule, the F is the denoted force is denoted by the thumb. First finger denotes the magnetic field, and the middle finger denotes the direction of current, or for a positive charge, direction of the moving charge. So if we place the direction of magnetic field along the direction of the magnetic field specified and the direction of moving charge along the middle finger, then the thumb which points towards the left gives you the direction of force. So out here the force will be directed towards the left. Why? According to the formula F equal to Q V cross V. Alright? Next question. I've taken a negative charge. Listen to it very carefully. I've taken a what charge? A negative charge, and I have thrown it towards the left in the same field. In the same field, I've thrown a minus Q charge. Minus Q charge towards the left. In the same magnetic field which is directed into the plane of the board, I've thrown a negative charge towards the left. Which direction will it experience the force? Now, look at this. Since it's a negative charge, when you're applying the Fleming's left-hand rule, you need to remember that the direction of current, that is the middle finger, which represents the direction of motion of the charge, should be taken exactly opposite to that of the given direction of velocity. Why? Only because the charge is negative. So, the direction of motion should be taken as this, but in here, to find out the direction of force, we should take the direction of motion towards the right. So magnetic field is inwards, okay, and the motion of the charged particle is towards the right, so it should experience the force in the upward direction. Or else, you can also do it in this way. Forget about the direction of motion in the previous first case. Just think of it as a positive charge. पहले positive charge के हिसाब से निकाल लेंगे, और charge negative है तो उल्टा कर देंगे, ठीक है? तो पहले charge को देखने का ही जरूरत नहीं है. Remove the charge. Velocity इधर है. मैग्नेटिक फील्ड किधर है? इनटू द प्लेन ऑफ द पेपर. तो ऐसा होना चाहिए, ऐसा होना चाहिए. तो किस डायरेक्शन में होना चाहिए? It should experience the force in the downward direction. Ideal situation, Fleming's left-hand rule says that it should experience the force in the downward direction. पहले निकाल लिया force का direction, उसके बाद एक बार चार्ज को चेक कर लेंगे. If the charge is negative, just invert the direction. Why? Because the charge is negative. Clear? Next question. The magnetic field lines are directed along this direction. The magnetic field lines are directed along this direction. Means this part to that. Okay? And a charged particle is thrown along the upward direction, and it's a positive charge with a velocity v. Which direction will it experience the force? Which direction will it experience the force? Question. So in this case, the magnetic field is directed towards the right. So Fleming's left hand rule, the first finger should be directed towards the right, and the charge is being shown in the vertically upward direction, and it's a positive charge. We'll look at it later. Okay, we'll look at it later. The charge is thrown in the vertically upward direction, so the thumb is pointing into the plane of the board. So it will experience the force cross direction. Will be the direction of force. Okay, now check the charge positive, so it's okay. Fine, not an issue. अगर ये negative होता तो direction change होगा. Right, direction change होगा. Okay, next question. Let's take up the next question quickly, and then we'll start with the these dots are the direction of magnetic field. These dots are the direction of magnetic field. Okay, sorry. Magnetic field. And a charged particle is thrown. We don't know which direction it is thrown. We can see that it is experiencing a force in the upward direction. It is experiencing the force in the upward direction. And it is a positive charge. Then which direction is it thrown? কোন দিকে চার্জ পার্টিকেলটাকে থ্রো করা হয়েছে অ্যাপ্লাই করে নি আমরা ফ্লেমিংস লেফট হ্যান্ড রুল তো obviously the direction of velocity is not known to us, so যেগুলো জানা আছে we'll specify those. First, the magnetic field lines, they are coming out of the plane of the board, that means directed along your direction. All right, next, it is experiencing a force in the upward direction, so this is the direction of the force experienced, hence it should be directed, the charge particle should be thrown towards the left. Alright, বুঝে আছে তাহলে ডিরেকশনাল সেন্স সবার ক্লিয়ার? অলরাইট, দিস ইজ ভেরি ইম্পর্টেন্ট। আমরা যে কোশ্চেনস গুলো ডাউটস গুলো আছে সেগুলো আমরা ডিসকাস করব অন মানডে। অলরাইট।